Good evening, everyone, and welcome to LSU Science Café. I'm Steve Beck with the LSU Office of Research and Economic Development, and we're excited to bring you tonight's program featuring research by Pennington Biomedical Research Center faculty. Live captioning for this event is available through the link that's being put in the chat box right now. Despite our physical distance, our goal is to build a strong, informed community by providing access to reliable information, new ideas, and cutting-edge research, scholarship, and creativity from faculty experts and researchers in fields across the university. This online event is being recorded and will be available with a transcription from the LSU research website within the next few days. And one lucky guest tonight will receive a goodie bag from the Pennington Biomedical Research Center. We'll announce the winner at the end of the program. And now, without further ado, I'd like to introduce tonight's program and speakers who will present some of their research on the connection between physical activity and mind and body health. Dr. Justin Brown is an assistant professor and the director of the Cancer Metabolism program at Pennington Biomedical Research Center. His research interests include discovering the mechanisms through which weight management, diabetes control, optimal nutrition, and physical activity prevent the development and progression of cancer. He received his PhD in clinical epidemiology at the University of Pennsylvania. He conducted a fellowship in cancer epidemiology at the Dana-Farber Cancer Institute and Harvard Medical School. Dr. Robert Newton, Jr. is an associate professor and the director of the Physical Activity and Ethnic Minority Health Laboratory at Pennington Biomedical Research Center. His research interests center on addressing health disparities in African American children, adults, and older adults. Most of his work involves developing physical activity promotion interventions, and he also engages in weight loss studies. Dr. Newton utilizes community-based and technology-based interventions to address the health disparities. He received his PhD in clinical psychology at the University of Florida. After their presentations, we'll have a moderated question and answer session. To participate, please use the Q&A button to enter your questions. We'll be monitoring that section and relaying them to our panelists. Now, I'll turn it over to Dr. Justin Brown. Dr. Brown?
Good evening, everyone. Tonight, I'm going to tell you a story about how cancer is like a dandelion. Right now, you might be thinking, how does a dandelion relate to cancer? But by the end of my presentation, I think you'll understand. Tonight, I'm going to explain the biology of how physical activity might prevent the development and progression of cancer. Physical activity is any movement produced by skeletal muscles that increases our energy expenditure. In the context of this talk, I'll refer to the subset of physical activity that enhances our health, known as exercise. So, what do we know about the relationship between physical activity and cancer risk? We know that individuals who engage in more physical activity are 10 to 20% less likely to develop at least 13 different types of cancer. These include common cancers such as breast, lung, colorectal, and kidney cancer. And I want to highlight two important observations regarding these data. The first is that the more physical activity you engage in, the larger the cancer risk reduction benefit. In research, we call this a dose-response relationship. That is, the larger the physical activity dose, the larger the cancer risk reduction response. The second is that the relationship between physical activity and cancer risk is independent of body mass index, or how much you weigh. What this means is that if you have overweight or obesity, if you engage in physical activity, you can achieve a cancer risk lowering benefit. Physical activity is an important component of a healthy lifestyle to reduce cancer risk. So what happens if you develop cancer? Can physical activity potentially help a person remain cured if their cancer was diagnosed at an early stage? Can physical activity possibly prevent a person from dying from cancer? The answers to these questions are yes. We know that patients diagnosed with common cancers, such as breast, colorectal, and prostate cancer, are 40 to 50% more likely to remain cured and 30 to 50% less likely to die from their cancer. One of the areas that we focus on at Pennington Biomedical Research Center is to understand what is happening biologically inside a person when they engage in physical activity that could prevent a cancer from coming back or causing death. To explain, I want to share with you an illustration. This illustration depicts the steps of cancer metastasis. Cancer metastasis is the process where cancer spreads from the part of the body that it has initially grown to different or distant parts of the body. What happens is that cancer cells, or clusters of cancer cells, detach from the primary tumor. They make their way into the bloodstream, survive in the bloodstream, make their way out of the bloodstream, and grow in other parts of the body. In this example, a cancer that started growing in the colon has spread to the liver. This is the process of cancer metastasis. This process causes 90% of all cancer deaths. So developing treatments that interrupt this process, either by preventing cancer cells from getting into the bloodstream, eliminating them while they're in the bloodstream, or preventing them from getting into other body parts, has the potential to impact the treatment of cancer. This is where physical activity has its greatest potential. In our research studies, we can measure cancer cells using a blood sample from a person who has had a cancer. These cancer cells that are in the bloodstream are called circulating tumor cells. These circulating tumor cells are rare. In 1 tablespoon of blood, there are millions of white blood cells and billions of red blood cells, and there may be only 1 or 2 circulating tumor cells. But using very sensitive laboratory techniques, we're able to reliably detect them. In a recent study, we have shown that physical activity can reduce the number of circulating tumor cells in the bloodstream. This study was done in patients who had completed their standard treatments for colon cancer, including surgery and chemotherapy. Participants were randomly assigned to engage in a physical activity program or continue their usual day-to-day activities. The physical activity group exercised for 30 to 60 minutes per day on most days of the week. The most common activity type was brisk walking. After 24 weeks, the group that continued their usual day-to-day activity had no change in their circulating tumor cells, whereas the group that participated in physical activity had a 35% reduction in their circulating tumor cells. So the next question is, how is exercise reducing these circulating tumor cells? We hypothesize that there are 2 biological processes that are occurring, and they're complementary to one another. The first relates to direct physical stress that is placed upon the circulating tumor cell during exercise. On the surface of the circulating tumor cells are mechanoreceptors that give the cell clues about the physical environment in which it is located. When we engage in physical activity, the velocity of blood flowing through our blood vessels increases. Think about it. Our heart rate increases, and thus more blood is flowing through our blood vessels. This rapid blood flow causes an increase in what is called shear stress in the blood vessel. This increased shear stress causes a very hostile environment in which the cancer cell is unable to survive. We hypothesize that when a person engages in a bout of physical activity, these mechanoreceptors on the cell surface send a signal to the cell that the environment has become too hostile to survive and induces cell cycle arrest and eventually death of the circulating tumor cell. The second mechanism relates to indirect stress that is placed upon the tumor cell both during and after exercise. On the surface of the circulating tumor cells are receptors for various nutrients and growth factors that provide stimulation for the cell to grow and survive. One such example is the insulin receptor. Our bodies use insulin to get glucose or blood sugar into the cells of various tissues, such as our muscles. But cancer cells use insulin as a growth factor. Engaging in physical activity enables our bodies to use insulin more efficiently, As a result, there's less insulin available in the bloodstream for cancer cells to use. And when bouts of physical activity are repeated day after day, the circulating tumor cells become deprived of the necessary nutrients and growth factors needed for survival. So these hypotheses represent our current thinking about how physical activity can prevent cancer metastasis and death. And we have ongoing studies to better understand these observations to enable us to provide more precise guidance about physical activity for cancer prevention and cancer survivorship, as well as to determine if these biological processes can be targeted by other treatments, such as medicines or diet, for people who may be unable to participate in physical activity. In keeping with the theme of today's series, How to Live Better, I want to offer you some tips that you can begin to lower your cancer risk of developing cancer. First, adults should move more and sit less throughout the day. Some physical activity is better than none. Adults who sit less and do any amount of physical activity gain some health benefits. Second, for substantial health benefits, adults should do at least 150 to 300 minutes a week of moderate intensity aerobic activity. And preferably, aerobic activity should be spread throughout the week. Third, additional health benefits are gained by engaging in physical activity beyond the equivalent of 300 minutes of moderate intensity physical activity a week. Fourth, adults should also do muscle strengthening activities that involve all major muscle groups and flexibility and balance activities on 2 or more days a week, as these activities provide additional health benefits. Furthermore, we know that avoiding tobacco products, consuming a healthful diet that's rich in fruits and vegetables, and minimizes the consumption of processed foods and sugar-sweetened beverages, and maintaining a healthy body weight or preventing weight gain are important health practices for cancer risk reduction. Doing some of these practices is better than doing none, and the more you do, the greater the health benefit that you achieve. Lastly, I want to encourage all of you to think about participating in research studies wherever you may be located. Research studies are the only way that we know what works to promote human health. At Pennington Biomedical Research Center, we very much take a participant-centered approach, meeting each person where they are in their journey, recognizing that each person is different. More information about our ongoing studies is available on our website, pbrc.edu. And for those of you who are not in the Louisiana area, you can find available study opportunities at clinicaltrials.gov. So coming back to the dandelion. Cancer's like a dandelion because they both grow unexpectedly and are difficult to get rid of. The dandelions have seeds, which, despite how delicate they are, easily spread to other parts of the yard. Those seeds are the circulating tumor cells that we discussed. And I hope that I've made a case as to how a dandelion is like cancer and how physical activity is a useful tool to prevent the development and progression of cancer. Thank you.
Thank you, Dr. Brown. And now it's my pleasure to introduce Dr. Robert Newton, Jr., who will speak a little bit about his work. Dr. Newton.
Thank you. Good evening, everyone. I want to thank Dr. Beck for inviting me to present at the LSU Science Cafe, and I also want to thank Allison, Holly, and Kristen for their assistance along the way. I also want to say that it is extremely difficult to put 10 to 15 minutes of science into one slide, so forgive me for overstuffing my slide a little bit. Tonight, I want to talk to you a little bit about the relationship between physical activity and dementia. So you might be asking yourself, is there a relationship between physical activity and dementia? My slide here shows an older couple exercising, and this is meant to represent physical activity broadly. The brain will represent dementia because dementia is essentially a disease of the brain. The arrow represents the path connecting the two. Dr. Brown already told you what physical activity is, so I'll define dementia. Dementia is defined as changes to cognition that are beyond what is normal and that adversely affect one's daily life and ability to function. Cognition is defined as your thinking skills, such as your ability to pay attention, to process information, to produce language, and of course, your memory. In order to begin to answer this question of is there a relationship between physical activity and dementia, we use what we call cross-sectional studies. It's like taking a snapshot of the population at any given time. These cross-sectional studies show that people who report doing physical activity have a lower likelihood of concurrently having dementia. Another way to look at things is to track people over time, and we call this longitudinal or prospective studies. In these studies, we would track people over a number of years while assessing their physical activity and their health. These longitudinal studies also show that as people stay physically active, they have less likelihood of developing dementia over time. These studies tell us that there is a correlation or a relationship between physical activity and dementia. But these correlational studies are not causal, meaning they don't tell us if one thing is causing the other. In order to get closer to trying to determine if physical activity is causing a reduction in dementia risk, we have to do experimental studies. So we have to ask, does physical activity reduce risk factors for dementia? Remember that we define dementia as cognitive changes or thinking skills, such as your ability to pay attention, process information, and produce language. So if someone experiences significant changes in any of these areas, it would be considered a risk factor for developing dementia. So in these studies, people engage in regular exercise for a period of time, say 6 months or a year or even longer. And at the beginning and end of the study, their thinking skills will be measured so that we can determine if there's a change over the course of the study. And the way that we assess these thinking skills is by giving people a test. And some of these tests may be giving you a list and asking you to recall what's on that list, or giving you a series of tasks that you have to complete in a certain sequence. These studies show that physical activity improves some thinking skills. This path, with the arrow leading from physical activity to thinking memory, shows that physical activity positively affects the risk factors for dementia, and therefore can reduce the risk of developing dementia, which is the curved arrow leading to the brain. It's similar to how physical activity can improve the ability of the body to get sugar out of the system, and therefore reduces your risk of developing diabetes. So the next logical question is, what are the mechanisms by which physical activity positively affects thinking skills? In other words, what does physical activity do to the body that results in positive changes in thinking skills? One possible mechanism is through brain-derived neurotrophic factor, or BDNF. This is a protein that promotes growth of synapses and enhances neuronal or brain cell function and repair. Studies have shown that physical activity results in an increase in BDNF, or this positive protein. Another possible mechanism is through inflammation. So having inflammatory factors or chemicals that result in inflammation in the body, it's not beneficial. Physical activity results in a reduction of these inflammatory factors circulating in the body. A third possible mechanism is cerebrovascular function, or the ability of the body to circulate blood within the brain. And you might have guessed that studies show that physical activity results in improved cerebrovascular function, much as physical activity improves the ability of the body to circulate blood throughout the rest of the body. Another potential mechanism is actual brain structure. So imaging studies using MRIs or PET scans show that after a physical intervention, there is an increased synaptic connections in certain regions of the brain that are associated with memory and language and thinking skills. So this path shows that physical activity positively affects certain bodily mechanisms, including good proteins, inflammatory factors, and brain function and structure, which then result in improved cognitive skills and thus are hypothesized to reduce the risk of developing dementia. So the next question that you may be asking is, what kind of physical activity are these people doing in these studies? Most of the studies target moderate to rigorous physical activity. And by this, I mean you're working your heart to about 65% to 85% of its maximal capacity, or the effort equivalent to brisk walking. The studies also try to get participants to exercise about 150 minutes a week of moderate to rigorous physical activity. This has been the recommendation by our government for a long time. And as Dr. Brown said, 150 minutes is good, 300 is better, and even more is better. The activity is usually spread over 3 to 5 days per week. Now, the kind of physical activity is usually aerobic, such as walking or riding a stationary bike. So that means most of the studies that I talked about, they used aerobic activity in order to increase activity in the participants of the studies. There's also a good number of studies assessing the effect of strength training. In other words, activity that helps to strengthen the bones and the muscles, such as weight training or resistance, or using resistance bands. Some of these studies have been done in isolation and others in combination with aerobic training. And some studies are showing that strength training alone results in improved cognitive function. Many physical activity interventions will also include balance and flexibility, but the independent effects of these types of activity are not really known. Many studies conduct physical activity in supervised environments where participants are watched every minute of their activity. So we know that their activity is in the moderate to vigorous range and the exact amount of time it's supposed to be. In terms of the strength training, people will know the exact number of repetitions and exact amount of weight that's lifted. A hybrid approach is where some of the activity is in structured environments and others is done at home. In studies where participants will exercise on their own, we may give them a device that helps us to track the amount of physical activity that they do. These hybrid approaches don't allow us as much control over the physical activity, but the devices help us to know what's going on. And other studies use a solely home-based approach where all of the activity is done outside of, a center. Across all of these different types of studies, though, they still show benefits on cognitive functioning or thinking skills. So the point is that you don't need supervised activity or a gym. You can do activity at home on your own, and you'll still get health benefits. Another benefit of doing physical activity is that it improves your physical function. And physical function is very important for an older population because we know that as you get older, it's harder to do routine activities requiring physical capabilities, such as getting up out of a chair or lifting objects. We also know that physical activity helps to reduce anxiety and depression. And we also know that mood changes can affect your cognition or your thinking skills. So physical activity helps to improve or reduce your risk of developing chronic diseases, which would improve your health. And improved health may also be related to reducing the risk of developing dementia, but these long-term studies are just beginning to show results. A newer question that's being asked is, what if we combine physical activity with other lifestyle behaviors? So here, the question is, if we do a study that tries to change multiple lifestyle behaviors, does it reduce the risk of developing dementia? These other lifestyle behaviors include diet, sleep, socializing, cognitive training, and managing chronic disease. In terms of diet, this translates into increasing the consumption of fruits and vegetables, reducing the intake of fats, increasing protein and fiber. In terms of sleep, it means improving the quality of your sleep. By socializing, I mean having older individuals have more interaction with other people and have specific activities that they would be doing. Cognitive training or thinking activities means engaging in specific activities designed to stimulate your thinking. Another term is brain games. By blood pressure meds, what I really mean here is managing cardiometabolic disease, such as hypertension or diabetes. One major study found that participants who were in the group in which they made changes to their diet, physical activity, engaged in cognitive training, and were counseled on how to manage their chronic diseases had improved cognitive function compared to participants in the group that received usual care after 2 years. So this path shows that if you add lifestyle components to physical activity, it can result in improvements in cognitive functioning that can then lead to the reduced risk of developing dementia. I should also note 2 other things. First, all the studies that I've discussed have been done in people who are not having any problems with their thinking skills. So a natural question is, do we see the same improvements in cognitive functioning from physical activity interventions in people with mild cognitive impairment or people who have dementia? Mild cognitive impairment, or MCI, is defined as when somebody begins to show deficits in any area of cognition. So it could be your memory, it could be problems generating words, it could be a slowing of the speed in which you process information, but it does not adversely affect your daily life. Several physical activity interventions have resulted in improvements in global cognitive functioning in individuals with mild cognitive impairment. These studies in dementia show that there may be a slowing, but not necessarily a reversal of cognitive decline. Second, research is beginning to expand into populations experiencing health disparities. For example, African Americans actually have double the risk of developing dementia compared to people from other ethnic groups. However, there are only 3 studies assessing the effect of physical activity on cognitive function or thinking skills in African Americans, and only 1 study has used a multi-component intervention. There are too few studies to draw any conclusions about the effectiveness of physical activity in underserved populations. So in sum, we know that physical activity is associated with a reduced risk of developing dementia in cross-sectional longitudinal studies. We also know that experimental studies show that increased physical activity results in improved cognitive function in some domains. And there are several potential mechanisms by which physical activity makes these changes, including increasing BDNF and through changes in actual brain structure and function. Most studies have attempted to have participants engage in 150 minutes of exercise at a moderate to vigorous intensity, several days a week, and have included strength training. Research is starting to look at the effectiveness of multi-component programs in which physical activity is combined with other lifestyle behaviors, and looking to determine if the effects of physical activity apply to different ethnic populations. So as Dr. Brown noted, I also encourage you to engage in regular moderate to rigorous physical activity consisting of aerobic, strength, balance, and stretching exercises 3 to 5 days per week, because there's a large number of large number of studies that show that they may be beneficial to your brain health. Thank you for your attention.
Thank you, Dr. Newton. And at this time, we will be starting to go through some of the questions that have been put in our question and answer section. So the first one actually is for Dr. Brown, I would believe, and it deals with the whether the reduction of incidence in cancer can be attributed to people exercising or not smoking because they're exercising. Specifically, they ask, can the reduction in the incidence of cancer in persons who exercise be attributed to a lower incidence of smoking by the persons who regularly exercise?
It's a great question. So we know that lifestyle factors like exercising and choosing to abstain from tobacco products often cluster, and people who choose to engage in exercise are generally less likely to consume tobacco products. The good news is the benefit of physical activity to reduce cancer risk is independent from that of smoking. Now, that doesn't mean you should continue to smoke. Quitting smoking or reducing your tobacco consumption is one of the best things you can do to improve your health. But the benefit of physical activity is independent of the effects of smoking.
Okay, that's really it's interesting. How did you have this determination that it's independent of smoking or not smoking? The benefit of exercise.
So a lot of the data that we have regarding the role of physical activity and cancer risk are derived from what's called prospective cohort studies. And what that is at the beginning of the study, participants answer questionnaires and complete a variety of measures regarding their tobacco consumption habits and their amount of physical activity. And then those individuals are followed longitudinally over time until some of them develop cancer and others don't. And what we can do is we can basically statistically account for the role of smoking in predicting cancer risk versus that of physical activity. So there's a variety of different analytic techniques we can use when we analyze the data to try to parse out the effects of smoking versus that of physical activity. But we know even in people who consume tobacco products, those who engage in physical activity have a lower risk of developing cancer than those who do not engage in physical activity.
That's great to know. Dr. Newton, so this the next set of questions actually comes your way. And one I want to kind of frame in terms of what you mean by dementia. And I know that dementia has a lot of different facets to it and a lot of different presentations. Are you speaking of dementia generally, or to include things like Alzheimer's, or is there a very specific kind of dementia that you're thinking about in the studies that you've been working on?
So, yeah, I probably could have gone into that a little bit more detail, but dementia really is an umbrella term for a bunch of disorders that affect the brain. And so Alzheimer's disease is, about 60 to 70% of people who have a dementia have Alzheimer's disease. But there's also Alzheimer's disease, dementia that's related to Parkinson's disease, and to there's other dementias outside of just Alzheimer's disease. So with all of these dementias, you have cognitive changes, meaning you have changes in the way that your brain is functioning, essentially. So most people will recognize that there's some memory loss that's going on. They can't seem to remember things that have happened recently. And that you may see changes in other cognitive domains as well. But really the hallmark for Alzheimer's disease and for a lot of other dementias is that memory loss. And so, really that's what a lot of the studies have been focused on is Alzheimer's disease. But again, because some of the symptoms are very much the same, and the definition being that you have changes in your cognitive functioning that then ends up affecting your ability to function every day. That's why we really focus on changes in cognition, as with a lot of these studies. So that's why when I was talking about physical activity, I was talking about changes in cognition, in the way that you're thinking, because that's really our risk factor for dementia.
And so if people are concerned about these early warning signs, what should they do? How should they, what kind of course should they take in terms of trying to get it addressed or assessed, more importantly?
Right. So, I encourage everybody who thinks that they're having some sort of cognitive decline, where you're noticing that something, the way that you're thinking, is not working well. So you're really struggling with remembering the names of things, like if you can't remember what the ketchup is, or if you're having problems with your memory where you really can't remember things that have happened really recently, within your day, and you notice that it's much different than what it was 5 years ago, 10 years ago, then I would encourage people to go to see their doctor. You're probably going to see most times dementia is occurring in older individuals. So you're going to see your primary care doctor, your gerontologist. And what they'll essentially do is they will refer you to somebody who will do neuropsychological testing, in which they'll test these cognitive domains, and they'll see if you're performing normal, if you're performing a little bit below normal, if you're performing a lot below normal. So the first thing to do if you're noticing that there's significant changes is to go see your doctor. And we also have to remember that, as we get older, people generally start to experience changes in memory and thinking, but these changes normal are not frequent, and they're not disturbing to the person. And so when it gets to that level, when you notice it is a large change from what it used to be, that's when it's time to go to the doctor.
So in addition to what you just described, you want to make the point that some memory loss is a natural part of aging, and that you need a medical professional to really be able to make a determination between what is normal memory loss and what might be a dementia.
Yes. So yes. So when you go to get see your doctor, or you go get a neuropsychological test, they'll be able to tell you if the kinds of changes that they're seeing, if they're within the normal range or if they're outside of the normal. And at that point in time, they'll either, prescribe some lifestyle behavior changes, or they may prescribe some medications, those kinds of things. And then they'll continue to monitor it. So yes, you're right. I really want to distinguish between what's normal and what's abnormal.
Well, and we had questions about that too. So that's why I wanted to make sure that we got that clear. Dr. Brown, I think this one is going to be for you, but actually for both of you. Someone asks about the kinds of moderate physical activity that would be considered good. Things like tennis or yoga. Does gardening contribute towards that? Do some of the exercise regimens help both in terms of dementia improvement, in addition to cancer improvement, or the ability for the body to kind of prevent cancer? So, Dr. Brown, if you start on that one.
Yeah, so my answer to that question is very pragmatic. And the best type of exercise or physical activity is the type of physical activity that you'll actually do, because we know that adherence to physical activity and exercise is very challenging for a lot of people. And so I advise, study participants to find an activity they love to do, because I want them to do it forever. And the thinking that I describe in trying to identify an activity is, when you do the activity, does it cause your heart rate to increase a little bit? Does it cause mild sweating or perspiration? Maybe cause you to get a little bit out of breath, but you can still carry a conversation. And that's kind of the litmus test that I provide as to whether physical activity is of moderate intensity. So the examples regarding tennis or yoga or gardening, those are all moderate intensity activities. And if those are activities that you like to do and you'll do them for the rest of your life, I would encourage you to do them, because we have to remember that little things make a big difference when they are integrated over your entire lifespan.
And Dr. Newton, is there anything that you would contribute to that?
I agree 100% with everything that Dr. Brown said. It is very important to do physical activity that you enjoy and that you can do for the rest of your life. Those examples are perfect examples of moderate to rigorous physical activity. So yes, and there have been some studies that have looked at the effect of yoga, on cognitive functioning, and those studies do show that engaging in yoga does help with some aspects of cognitive function. So I concur with everything Dr. Brown said.
So someone poses a really interesting follow-up question that actually I think connects improvement in sleep quality to some of these other aspects, and I think specifically with regarding dementia. She asks, does the increase in exercise also improve sleep quality such that it would impact the reduction in dementia, or are there biochemical improvements of exercise that are independent of improved sleep? Dr. Newton.
Yeah, so to answer the first question first, or the second question first, there are biochemical improvements in exercise that are independent of improved sleep. There are also studies that show that physical activity does improve sleep quality. So you can get synergistic effects by doing physical activity on your sleep. And there haven't been a ton of studies that have looked at sleep independently of everything else on dementia risk. But what we do know is that people who don't sleep well also don't perform well on cognitive tests. And that's largely because your brain just isn't functioning optimally, which is why we oftentimes tend to do our cognitive testing in the morning, because we know that people get fatigued, and that will affect the cognitive testing as well. So yes, the exercise has effects independent of sleep. Yes, exercise can affect sleep quality, and sleep can be related to your cognitive function or lack of sleep.
And Dr. Newton, does your research include studies with relation to vascular dementia?
No, the studies that we have done or that we're currently doing really relate to Alzheimer's disease. And so we're looking really at those biomarkers and risk factors for Alzheimer's disease and not vascular disease. But in terms of vascular disease, that again, physical activity, because of its effects on getting inflammation out of the blood, increasing circulation, in the brain, which tends to get out chemicals and provide nutrition and those sorts of things, that physical activity is thought to be beneficial for vascular dementia as well.
So we have a question. I'm not sure whether either of you have experience with this, but I'll throw this out there. Will physical activity help with diabetes? I think the person wants to kind of understand whether their particular A1C numbers might change simply because of age. How does exercise impact that? I don't know if either of you can have the experience to answer that, but I'll throw it out there just to kind of get your response.
Sure. So a scientist here by the name of Tim Church did a study a number of years ago where he looked at individuals who had diabetes and looked at different combinations of exercise. So just aerobic, just strength, and the combination of aerobic and strength over 9 months. And what they showed in that study was that the combination of doing aerobic exercise and strength training reduced A1C levels more than in the aerobic or strength alone, and more than in the control group. So yes, increasing physical activity does result in changes, can reduce your A1C. We know that physical activity can reduce your risk factors for developing diabetes. So the answer to that question is yes. And that's not the only study. There are several other studies that show similar effects.
Dr. Brown, could you talk a little bit about kind of the studies that do go on at Pennington and how people might be able to participate?
Yeah, so we conduct a variety of studies. Dr. Newton and myself conduct studies in cancer prevention and control, as well as cognitive health and minority health. But we have colleagues who study warfighter health and how to lose weight efficiently and keep it off. So there's a variety of studies that we conduct at Pennington that all thematically relate to metabolic health. That is physical activity, body weight, body composition, healthy eating and nutrition, and diabetes control. And for individuals that are interested in learning more about potential studies that we have ongoing, I believe the link has been posted on the chat. But for those of you who can't see, if you go to pbrc.edu, right at the top, there's a button that says research studies, and it's updated probably weekly. And I think the last count, we have 35 to sometimes 50 clinical trials going on at any one time. So it doesn't mean you'll be eligible for all of those studies, but you can poke around and see if there's a study that piques your interest. And it's as easy as clicking a button and entering some of your information. And we have staff that are trained and can reach out to you to be able to provide you with more information about the study and to determine if you're eligible. We really do try to make it an easy process because we recognize that the only way we can advance human health is through volunteers who participate in research. So we really try to make it worth your while and make it easy for people in the community to participate in our clinical studies.
That's really excellent news. So let me also throw this to both of you. We do have a question about baby aspirin and the benefits of baby aspirin. I know that there was a big study, and maybe it's still going on at Pennington regarding baby aspirin. Can either of you speak to that? And does it contribute to either of the areas in which you're doing your research?
So I can comment first. So the study that is referenced is called the Aspirin study. And it was a study that evaluated the benefits of aspirin in older adults on a variety of different health outcomes. And the results from those clinical studies demonstrated that there's a bit of a mixed benefit to taking baby aspirin. And so my advice would be if aspirin for any reason is of interest to you, you should talk to your doctor because there are unique benefits, but also unique risks. And it really should be a patient-centered decision that you have in consultation with your doctor, who will be able to talk you through the different benefits, but also the potential risks that may come from taking a baby aspirin.
Dr. Newton?
No, I agree with Dr. Brown. yeah, the findings are have both positive and negative, and it is extremely important to talk to your doctor if you're thinking about taking aspirin on a daily basis.
Here's a really interesting question. Does the time of day one exercises increase the impact of the exercise on either warding off cancer or dementia? Is there some correlation between whether you're exercising in the morning or evening, before you get up, or right after you get up, just before you go to bed, middle of the day? Where does that, is there anything there?
So there have not been any studies that I know of that have looked at the effect of time of day in which you exercise on cognitive function or reducing the risk of dementia. I know that there are studies going on now that are trying to answer this question in other areas of science in terms of diabetes and hypertension and things of that nature, but there haven't been any that have been done in terms of cognitive function and brain health. So I would advise people that find a time that works best for you and stick to that time, because there's nothing that suggests that a certain time of the day is substantially better than any other time of the day.
Yeah, and it's really the same with cancer. The timing with which we exercise is a relatively new concept, and studies are ongoing to try to understand if exercising at a certain day provides incremental health benefits over other times a day. Again, my advice is pragmatic in the sense of pick a time of day that you can exercise and do the exercise. That's the most important thing. We do know, however, that people who exercise at a consistent time, consistent early afternoon exercisers or consistent morning exercisers tend to be more adherent over the long term. So the goal is really to think carefully up front about what is the best time of day and pick that time and try to stick with it, because compared to people who sometimes exercise in the morning, sometimes exercise in the evening, their adherence to exercise programs is generally lower, probably because they just have less structured or more chaotic schedules. But if you can pick a time of day and do it consistently, that is the best way to achieve health benefits of physical activity.
So the bottom line is be active. It doesn't really matter when or where, just do it. Like they say on the Nike commercials, just do it.
Exactly.
Okay. Well, so I want to I'm not sure if you have any answers for this, but we're all aware that we're in the midst of quite a pandemic and really a unique health situation for our society and our world. And I'm curious as to the impact that may have on both dementia and cancer and general health in broadly speaking. Is there, the fact that we're staying at home more, that we're indoors rather than outdoors, that we're in a situation where we may not have the opportunities to do the kind of exercise that we would otherwise do. What are the things that we can, well, first, do you know of any studies at this point that might point to the impact that COVID-19 disease will have on the general population in these regards? And do you have any recommendations other than find a way to exercise?
So there was a study that was done at Pennington. The results just came out or will be coming out. And, it showed that the COVID has really reduced physical activity in people, increased their sedentary behavior, has affected their increased anxiety, and has had those negative effects. But it also resulted in people eating at home more. So, there's sort of a mixed bag there. And the impact it has had, in terms of studies is that, it has impacted studies, especially those that are going on in older adults. It's kind of slowed those down because we have these recommendations by our governor, and we know that the risk for contracting COVID and death is higher in older individuals. And so studies have been slowed down because of that, because we don't want to expose older individuals to increased risk. So yeah, that's the study from Pennington that I know of so far about the effects of COVID on lifestyle behaviors.
Yeah, the pandemic has taken a toll on each of us in very unique and unpredictable ways. My response is that little things make a big difference for your mental health, for your physical health, for your spiritual health. But we do know that particularly with respect to the benefits of exercise, there is we kind of say it tongue in cheek in the research community, but if you don't use it, you lose it. That is, if you don't exercise your muscles, exercise your lungs, you lose your muscle strength, you lose your fitness capacity. But we know that even doing little things over the course of a week actually can help to reduce the rate at which those fitness gains are lost. So little things make a big difference. But I think we are in a situation right now that we've really never been in before. And we just have, and it's a very dynamic situation. And we each just have to go one day at a time, but recognize that little things, when integrated over the course of our life, can make a very big difference for the health outcomes that each of us will be able to achieve.
So someone asks actually exactly about that particular issue, that, is there a time frame where you lose the benefit of having been active, very active in the past? I know that when I was younger, I used to swim all the time, and I was quite avid about it. As I've gotten older, it's gotten harder for me to do that. Is there, if we were active earlier on in our lives, how does that benefit carry on, or do we still need to maintain an active lifestyle?
You definitely need to maintain an active lifestyle. There's studies on detraining, and I have not done these studies on detraining, but is the rubric that I've always gone by, or that I've always heard, is that after about 2 weeks, the effects of exercise, 2 weeks of not doing exercise, they start to wane off. Now, how long does it take for those effects to return to baseline or to get worse than you were beforehand? I'm not exactly sure, but it is very important to continuously engage in exercise on a weekly basis, or else you do lose the effects of it.
Okay. Well, is there anything else that you'd like to add to this? I mean, this time frame, in COVID has really been quite a shock to all of us on so many different levels. How has it affected your research specifically? Not necessarily the outcomes in terms of what people can expect, but the actual work that you've done. How has COVID affected your ability to continue your research? I'll start with Dr. Brown.
Yeah, so early in the pandemic, before the state of Louisiana had shut down, there were reports emerging from Europe and from Asia that having cancer or having a history of cancer was a risk factor for having poor outcomes with COVID. That is, individuals with a history of cancer were more likely to require admission to the intensive care unit. They were more likely to pass away as a result of COVID. And so early in the pandemic, we made the decision that to protect the well-being of our study participants, as well as our staff, that we were going to suspend all of our clinical trial recruitment activities. And our recruitment was suspended for almost 200 days. And we are now slowly re-emerging and starting to begin our recruitment again. And we've learned a lot of lessons along the way, but our commitment from the very outset was to protect the well-being of our study participants, or those who are interested in volunteering in our studies, and to protect our staff. And we've learned a lot of important lessons to be able to do so safely. So we are slowly getting back online, but ultimately we did have a 6-month period where we were not enrolling any new participants in our clinical studies.
Dr. Newton, how about you?
So our studies were being conducted in older African-American adults. So we have a population that African-Americans are at higher risk for contracting COVID and for being hospitalized. We know that there are some reports that show that African-Americans actually have a higher risk of death from COVID. And we know that older individuals have the same profile, higher risk of contracting COVID, hospitalization, and mortality. So we made the decision to pause our study because it involved bringing individuals together in sort of in group-based sessions. So we're still paused. We anticipate being able to start in January. And so what COVID is, so that's the bad side. But it has allowed us an opportunity to do some COVID-related research, and at least to start some COVID-related research. So we're interested and we're anxious to get those studies started. And we're also starting a study in which we're going to look at the effect, the perceptions that African-Americans have about their willingness to participate in research. So we're going to we have that study that's just getting off the ground. And so we're hoping to get some good information there. So the effect has been, it stopped our studies, but it's given us an opportunity to study the effect of COVID and its effects on the population and their willingness to participate.
Dr. Newton, Dr. Brown, thank you so much for an engaging presentation and a discussion tonight. I really appreciate the time you've spent with us and shared with us the work that you've done. I know that our audience has really enjoyed our conversation. Tonight, we'd like to announce that tonight's lucky winner of the Pennington Biomedical Research Center goodie bag is Rose Sand. Pennington Biomedical will email you for your mailing address and make sure that you get the goodie bag as soon as possible. I'd also like to personally thank all of our staff, Holly, Kristen, Allison, Lisa, for making all of this possible tonight. It's been a great presentation. And we hope to see you again next month on Tuesday, November 17th at Science Cafe Talk on Wild Turkeys with Dr. Brett Collier with the LSU Ag Center School of Renewable and Natural Resources, and Dr. Cody Sedetol, the state small game program director for the Louisiana Department of Wildlife and Fisheries. Thank you all for attending. This concludes our closed caption service. Thank you very much, and we'll see you next month.